Hi again. Here we have another example where M1 of 5 kg on a frictionless table is connected to M2 of 2 kg by a massless string over a massless and frictionless pulley. We would like to find the acceleration of the masses and the tension in the string. We have M1 5 kg, M2 2 kg, and we want to find the acceleration of the system. And M1 accelerates this way and M2 accelerates this way with the same magnitude, right? Both accelerate with the same magnitude. But acceleration of M1 is to the right, acceleration of M2 is downward. All right? Let's draw free body diagram for M1. Free body diagram for M1. So this is the tension force is acting on M1 in horizontal direction, the normal force in the vertical direction, and M1G this way. Alright? This is X, this is Y. So if you apply Newton's law in the Y direction, because the acceleration also is this way, acceleration doesn't have Y component. Sum of Fy is equal to 0 gives you n equal to mg. That's not useful. You want to look for a and t. None of them is in that equation, so that's not very useful. But we can apply Newton's law in the x direction. Sum of fx equal to max. Sum of fx means that x component of these three. The x component of n, x component of mg are 0, right? The only x component is t magnitude. So t is equal to m, which is m1, times x component of acceleration. What is the x component of acceleration? Acceleration is this way, so x component of acceleration is the same as its magnitude. So we get a, right? We want t and a. These are magnitudes now, but we cannot solve it because we have two unknowns. But nevertheless, it's a very good result. But then we apply Newton's law for the other one, for M2. For M2, if we draw a free body diagram, X and Y, this is M2, the tension force applied upward, because remember we said tension force is always from the object toward the rope or string, right? This tension force applies upward and M2G applies downward. And the acceleration is also downward. Magnitude of this acceleration, magnitude of this acceleration are the same because these two are moving together. Also, if you have a massless string and massless pulley and frictionless pulley, the tension force here and here is the same, right? And remember, when you have massless string, massless frictionless pulley, the tension force only identically transfers to the other side. The reason is also Newton's law. We can discuss that, but I don't go into the details of that. You will see later when pulley is not massless. All right. So we have nothing is in x direction. So x direction is not going to help you here, but you can say sum of Fy equal to may. And sum of Fy means what? Means t, magnitude, because this is in the y direction, minus mg, because it's in the negative y direction, equal to m2 times y component of acceleration. Y component of acceleration is what? It's the same as magnitude, but negative, right? Because it's downward. Negative magnitude. Now we have this equation and this equation for two unknowns. You see here, if I write, if I replace t in here by m1a, if I replace this t in this, you get m1a minus m2g equals to negative M2A. And if I solve for A, what do I get? I move M2G to the other side, M2A on this side. I get M1A plus M2A equal to M2G. And you can say M1 plus M2 times A equal to M2G. And now I can solve for A, but before we do that, I want to take a look at this equation. What does this tell you? You see, this M2G is the net force acting on the system. This is M2G. There's tension force here. There's tension force here. And this is M1G and the normal force. M1G and normal force cancel each other. And if you take an axis going like this, like one object moving in that direction, both as the system as one object, the net force here is M2G. And the total mass is M1 plus M2. This tells you M2G, the net external force, is equal to total mass times acceleration. You see, Newton's law applies to the system of objects together. We're going to see that in more detail in chapter 9. So acceleration is just M2G, the net external force, divided by M1 plus M2. So acceleration will be 2.8 meters per second squared. So it's basically solving two equations, two unknowns. And then once you have the acceleration, we can put it back in this equation. M1 times A becomes T. So T becomes 5 times 2.8. T equals to 14 Newton. All right? Any questions? So you see, there are a few things here that you need to consider. First, the acceleration of this M1 going to the right is the same as the acceleration of M2 going down, right? That's very important because the length of this string is fixed. So if this goes this way 1 meter, this one goes, the M2 goes down by 1 meter at the same time. So the speeds and velocities, everything is the same. So the rate of change of velocity is also the same. So the accelerations are the same. Okay? So acceleration of the two objects are the same magnitude, but of course for this one is in the x direction or horizontal. For this one is vertical. Another thing is because there's massless and frictionless pulley and massless string, the tension force is identical. Only the direction is changing. All right? Now, we use this to find tension force. So obviously this equation holds with these numbers. But this equation also holds. If you do 14 Newton minus 19.6 Newton equal to 2 times negative 2.8. Right? You see the Newton's law applies to each one individually, also applies to both of them as a system as well. So every time you solve a problem, you should look and see, does this make sense? Does it make sense for this one? Does it make sense for the other one? For example, some of you said that the tension force should be equal to the weight of M2. That is only if the M2 doesn't accelerate, because if the force up and force down is the same, means the net force is 0, so it shouldn't accelerate. But you know it accelerates, so that's not the case, right? So be careful. You have to really pay attention to details here. Thanks for watching this video. Thank you.